Ladies and gentlemen, thank you for tuning in to our podcast on chirality. Chiral objects are objects that have left and right-handed forms. In other words, they are totally different objects. For example, if you put your left hand into a mirror, what are you going to get on the other side? You're actually going to get your right hand. Again, a different object. Another great example. If we put an American vehicle, a typical American vehicle in a mirror, big old mirror, what are you going to get on the other side? Not an American vehicle, but in a British vehicle. The steering wheel is going to be on the opposite side. The letters are going to be on the opposite sides, GM, MG, for example. Again, two totally different objects. Now, in organic chemistry, we're going to look at chiral molecules and atoms. For example, let's take a look at cis-1,2-dichlorocyclopentane. If we look here, we can see here that the H's are both cis, the Cl's are cis, facing the same direction. If we put that across a hypothetical mirror here, we're going to get the same molecule. If you take this molecule, you shift it over, boom, same thing. That is achiral. That is an achiral object. Now looking at the trans version of 1,2-dichlorocyclopentane, you can see the chlorines are anti and the H's are anti. If we put that across a mirror, boom, we get a different molecule here. We cannot shift this over and create the same thing like we were able to do up here. That means it's an enantiomer. An enantiomer is a molecule which is different from its mirror image. Now, why do I say there are two of these? Simply because if we put the chlorine up here and the H down there, as well as switch them up here, we will get a different molecule again. That's why there are two enantiomers. Now, the most common way to tell if a molecule is chiral or not is to look at the carbons within it. So, if we have a carbon that is attached to 4 different things, that is an asymmetric carbon, also known as a chiral carbon. Like so. Looking at this molecule right here, we have C2H5OH, and NH2OH, and H. 4 different, completely different substituents. That is a chiral carbon. We often denote it by a little asterisk there. Now, moving on to this molecule, would this be chiral or achiral? Ladies and gentlemen, it will not be chiral. The reason being is because, as you can see, there are 2 of the same substituents here. 1, 2, and these right here are the same. That is an achiral molecule. Now moving on to this last example here, we have, again, an achiral compound. Looking at this, one substituent, different substituents, and this right here would be considered, each of these considered the same substituent. If you put this down a little hypothetical mirror again, mirror image, you can look at that as being the same substituent. These 2 molecules are achiral. Thank you so much. Good luck.